Clear in my throat. KP the Math G talking here with you now. Appreciate everyone who is tuning in and who have been tuning in to these lessons. I got a whole bunch of good lessons that's going to be from the 2011 AP exam. I know that probably you are getting ready to take your final exam very soon if you haven't already, especially your AP students. As for your calculus students, I really don't know your schedule, but maybe you're still working toward this semester to work on your grade in calculus. And at any rate, we will help you in any way that we can to prepare you for the upcoming or for any upcoming test you may have. These are nice questions here. I want you to be familiar with these. Particle P is moving along the x-axis. For T is T being between 0 and 6, whatever, seconds, minutes, whatever, hours. And we have both functions. V at t is equal to 2 sine e t over 4 plus 1. A at t is acceleration, so velocity and acceleration. 1/2 e to the t over 4 cosine e to the t over 4. Alright, now, is the speed increasing or decreasing at t equals 5.5? Now, how do you find that? And you probably know, but in case you don't, or you've forgotten, or whatever, the idea is that you get the what you understand what you have to do. All right, so what we have to do is this. We got to find V at 5.5 and A at 5.5. Now, how do we know if the speed is, say, increasing? Yeah, that's right. If both V, the sign for V, let's say V is positive, then if A is positive, we have increasing. All right, the speed is increasing. Or what's another option? That's right. If both V and A are negative, so they have to have the same signs, that would be increasing. If the velocity is positive and the acceleration is negative, or if the velocity is negative and the acceleration is positive, if those signs differ, then the speed is decreasing. Okay, so you already have the functions for V and for A. All you have to do is plug those in. Now, what I did is I put them into y equals, into that y equals, all right, like this. I got y0 and y1. You may have y1 and y2. And actually, I put the velocity one first, and then I put the acceleration one in first, and then the velocity one second. Don't know why, but then again, I did that. And then what you could do is once you put them in there, just like this. I don't know if you can see this. Let me see if I can get it to you where you can see this. This is on my phone. You can see that. Well, the two functions are in y0, y sub 0, and y sub 1. Okay, and you see that right there. Okay, well, put those in there so that you can go to well, hold on. I'm trying to get out of that. Well, hold on. Okay, I'm trying to get out of this, and all right, now there we go. Now you can do. I'm going to do it again. Just I've already done it before, but I'm going to do it again. All right. So the first thing I'm going to check. You can check either one first, but you can get into alpha. Well, in my case, I have to get into alpha, and you might get into var and then y var on your calculator. But in my case, I have to get into alpha and then y var, and then I'll pick one or the other. I'll start with y-o, and then I will just simply put 5.5 into that. That's what you're doing. You're substituting that in there and closing the parentheses. Alright, then you just simply hit enter. And in the first case, alright, when I put the acceleration in, let me show you what I got. Okay, for that. Alright, acceleration. I got an answer here. It is negative. That's all that matters, is that it's negative. Oh well. Alright, so this one's negative. It's negative something. We really don't need to know the value of it other than the sign, really. So negative 1, we'll just go ahead and say 1.358. Then you might want to put this in your, you might want to write that one down. And then, okay. And then again, alpha, y var, this time y1, that's going to give me my velocity. Okay, and still 5.5, that's what we're dealing with. Alright, close parentheses and enter, and that's another negative number, 0.453. So 453. Okay, and I can go like that, that's fine. Alright, and so you say that the speed is increasing, and say because the signs for both V at 5.5 and A at 5.5 are negative. Alright, and if they were both positive, that would still be the same thing. Or you might say, are both the same, or are the same, maybe like that. The same. The signs are the same. Alright, there it is, like that. Okay. And maybe, that's the one reason mainly the reason I picked this problem is that so you could get some review on this speed. Alright, so speed is going to be the key word you look for, increasing or decreasing. Okay, signs are the same, so the particle is increasing. You might not just block it in, you might want to say the particle is increasing. Okay, and at t equals 5.5, because the signs for both velocity and acceleration are the same. Okay, there's that one. And you just remember that. Okay, just kind of keep stuff like that in mind. Now, I'm going to actually wanted to do just D. I'm going to briefly go over. I'm just going to set it up for you. So, or maybe you could help me set it up. Okay. All right. Now, I'm actually wanting to do D, but I'm going to quickly go over B and C. It says average velocity on this time frame. Average velocity. You can either do, alright, so right here on this time, 0 to 6. Okay, but average velocity would be 1 over 6 minus 0. Alright, like that. Like that. And then that would be V at t dt. And if you already have that in there, you can get your answer. By the way, I already have the answer is 1.949. So about equal to 1.949. Alright, and that's average velocity, so that would be in whatever, feet per second. Okay, that's what you're measuring. Some people do it like this. Okay, they'll just say this divided by 6, like that. Every which way you want to do that. Or if you want to do 6 minus 0 like this, that's fine. Still 6. Alright, but average is what you do there. You're going to multiply by 1 over, alright, the difference in the integrands, and or you can divide by the difference in the integrands, okay? Alright, there's that one. Very quickly. That's B part. Alright. C part is total velocity. Okay, total velocity is simply from that time. All you got to do is put the absolute value bar around this V at t dt. Alright, like that. Alright. That is the total. Actually, we're talking about total distance is what we're talking about. Not total velocity, total distance. If I said velocity, I was wrong. Alright, total distance. Because remember, when you take the antiderivative of velocity, we're talking about either position or distance. Alright, same thing really. We're talking about, in this case, total distance. Okay? Alright. Difference between average velocity and total distance. So that's what you got to remember. Okay? Alright, so there that is. Alright. Now D part. And this is what I wanted to get off to. Alright, so this is D part. Oh, by the way, C part, by the way, was 12.573. Just in case you didn't get that answer. 12.573. That's total distance. Okay. For t being between 0 and 6. Okay. The particle changes direction only exactly once. The particle changes direction. Alright, the velocity, if it's going this way, it changes direction, or if it started going this way, it changes direction. Alright, like that. Okay, so that's what I'm talking about. So changes direction when the velocity is 0. That's what you got to remember. Alright, changes direction. Alright, exactly once. Alright, that's what we're looking at. Alright, exactly once. Alright, find the position. Alright, now find the position. Well, remember now, x at 0 is already at 2. The position at t equals 0 is already 2. Alright, it's already initially 2. Alright, so that's one thing we got to realize is that we are dealing with that. Now, if we're looking for position, we need the position equation. We have the acceleration, we have the velocity. Integrate velocity, we're going to have the position equation. But it's going to be at the time that it turns around. It's not going to be from 0 to 6. Do not make that mistake. So what we got to do is find out where exactly does this turn around. All right. And I know it's going to be b at t dt, but before we do that, we got to figure out when it turns around. Well, it turns around, just like we said, when the velocity is equal to 0. So what we'd have to do is set this equal to 0. And to me, when I set that equal to 0, I want to find out where that crosses the t-axis. Alright, so right here, somewhere along here, somewhere between 0 and 6, it's going to cross either down or up. It's going to cross. Alright, and it's, you know, somewhere in there, I don't know, but or it may cross from the other side, but somewhere it crosses several times, but only from 0 to 6. Like they said, it crosses only one time there. We got to find out where that is. So what I did, again, and this may help you, I already have in my got y equals. Now mine is y1, that's my velocity, and I want to find out where that crosses. So once I put that in there, I can immediately figure out where that crosses the t, or in this case t-axis. Alright, so when I graph that, alright, I'm going to get something like this. Okay, so let me show you the graph. I don't know if you can see it from me showing you, so I'm just going to show you right here. Let me see if I can find something here. Okay, it's going to look something like this. Alright, so I've got on my, here's 4 right, well, 4 here, and somewhere, well, it's going to go further over. Okay, I'm sorry, apologize for that. Alright, so somewhere over here at 4, and then over here at 6, it is crossing like this, somewhere between 4 and 6, right in there. And we got to figure out where that point of intersection is. Now that is called a root. Sometimes it's called or a zero. It depends on what your calculator uses. So if you want to find the root or the zero, that's where that crosses that t-axis. Alright, t being between 0 and 6. You want to find that. You either use that, and mine is root, so I can just simply get down here and I can just hit root right there, 5.19552. 5.19552. So there it is right here. Alright, so my goodness, where are my colors here? Alright, here it is. 5.19552. 5.19552. Alright, and that is what I do there. You got to remember to do the 2 plus, and then once you do that, okay, I'm going to try to hurry now so I can get into this. I already have the answer. Alright, and then I added plus 2 to that. Okay, I went ahead and did this first. Alright, and then I added 2, or you can add the 2 first, it doesn't matter. Alright, you do get an answer of 14.1347, 14.135. So the position is 14.135. It's at t is equal to, so it's, well, so if x is 0 is at 2, then this position now has moved to the right, okay, to 14.135, okay, and that's where it is. All right, so x at 5.19552 is right here. We know what x at 0 is, but we have already got that plus now. You can't forget this. That's the key to understanding this. This is given for a reason. This usually you're going to find position. Where is it? Alright, so you take the antiderivative of the velocity, that's going to give you your position equation, or your position where it is, okay? And that's it. Just don't forget this. V at 0 is equal to, or x at 0 rather, the position is equal to 2. Not V at 0, but x at 0. Alright. Alright, so it's that plus this. And remember, it had to be at this time, not 6. Okay, it's at this time. Alright, find the position of the particle at that time. Alright, that time would be where we find this right here. That's this number right here. Right there. That's that number right there. Okay? Alright, and again, those are problems that, you know, could occur on that test. And you need to be familiar with those types of problems. So anyway. Alright, KP the Math G, this is, I'm getting ready to sign off with my signature clap. But before I do that, make sure that you subscribe if you would like to. Make sure if you'd like to make a comment, please do so. If you'd like to hit that like button, oh, I get smiles all over my face when I see that like button. But mainly whatever you want to do with that, that's up to you. This is for you. Okay, it's not for my glory, it is for you, for yours, and to help you gain a better understanding of this. Next time I want to get into, and just so you might know, we're going to talk about the temperature of tea and biscuits. That would be question number 2 if you'd like to look ahead. 2011 question number 2. So if you want to look at that ahead of time, you're welcome to do that. But again, this is what I'm going to do. And I think I'm just going to look at, well, we may look at all of them, okay? We may have to do a lesson or 2 on that one, okay? So I'm mainly interested in C and D, okay? Because I think you're familiar with A and B. Alright, so we'll do probably C and D on that one. Alright, KP the Math G signing off. Ladies and gentlemen, have a great, great day.